What if the Earth wasn't the center of the universe? This revolutionary question sparked one of the greatest scientific transformations in human history. At the forefront of this shift stood a man whose discoveries challenged long-held beliefs and altered our understanding of the cosmos forever. Galileo Galilei. Galileo, often regarded as the father of modern astronomy, made profound observations in the late 16th and early 17th centuries that upended centuries of scientific and religious doctrine. During his time, the prevailing belief, backed by the powerful Catholic Church, was that Earth lay at the center of the universe, with all celestial bodies revolving around it. But with his telescope and insatiable curiosity, Galileo would prove otherwise, at great personal cost. A century before Galileo, the Polish astronomer Nicholas Copernicus proposed a radical theory known as the heliocentric model, the idea that the Sun, not the Earth, was at the center of our solar system. Though groundbreaking, Copernicus's theory remained largely speculative until Galileo came along, armed with the technology and intellect needed to prove it. Galileo's rigorous observations validated Copernicus's ideas, providing undeniable evidence that would challenge centuries of belief. Galileo's curiosity manifested early in his life. As a student at the University of Pisa, he was intrigued by the motion of pendulums. One day, he noticed the steady, rhythmic swinging of a chandelier in the cathedral and observed that it took the same amount of time to complete each swing, no matter how far it moved. Using his own pulse as a timing tool, since clocks were yet to be invented, Galileo confirmed that the pendulum's motion was consistent. This realization laid the groundwork for the invention of the pendulum clock, a key innovation that would revolutionize timekeeping and, by extension, human productivity. His talent for observation earned him a teaching position at the University of Pisa. It was here that Galileo famously refuted one of Aristotle's long-held beliefs, that heavier objects fall faster than lighter ones. To prove this wrong, Galileo allegedly conducted a dramatic experiment by dropping two objects of different masses from the Leaning Tower of Pisa. He demonstrated that, in the absence of air resistance, all objects fall at the same rate. This discovery not only contradicted Aristotle, but also set the stage for future developments in physics, particularly the laws of motion. Despite his scientific triumphs, Galileo's contrarian nature did not sit well with his colleagues. After just a few years, his contract at Pisa was not renewed, likely due to his defiance of established ideas. Nevertheless, he secured a position at the University of Padua, where he continued to teach and make groundbreaking discoveries. It was in Padua that Galileo encountered the invention that would define his career: the telescope. Although originally designed by Dutch spectacle makers for military purposes, Galileo saw its potential for studying the heavens. After building his own improved version, he turned it skyward, beginning a series of observations that would revolutionize astronomy. In 1609, Galileo pointed his telescope at the moon, expecting to find a smooth, celestial body. Instead, he discovered craters, mountains, and valleys, revealing that the moon was far from the perfect sphere Aristotle had described. This was the first of many observations that would challenge the conventional view of the cosmos. Soon after, Galileo made an even more startling discovery: 4 moons orbiting the planet Jupiter. These moons, now known as Io, Europa, Ganymede, and Callisto, directly contradicted the belief that all celestial bodies revolved around Earth. If Jupiter had its own moons, then surely not everything orbited our planet. This finding provided concrete evidence that the Earth was not the center of the universe. Galileo's observations didn't stop there. When he observed Venus, he noticed that it went through phases similar to those of the Moon. This phenomenon could only be explained if Venus orbited the Sun, further supporting the heliocentric model and casting further doubt on the geocentric view supported by the Church. His discoveries, while scientifically groundbreaking, quickly put him at odds with the Catholic Church, which maintained that the Earth was at the center of creation. Galileo, a devout Catholic himself, tried to reconcile his findings with his faith. In letters to his students, he argued that Scripture was written from an earthly perspective and should not be taken as a literal scientific text. However, his attempts to bridge the gap between science and religion fell on deaf ears. In 1633, Galileo was summoned to Rome to face the Roman Inquisition. Charged with heresy for supporting heliocentrism, he was forced to recant his views publicly. To save his life, Galileo agreed to plead guilty, and in exchange, he was sentenced to house arrest, where he would remain for the rest of his life. Though he was forbidden from teaching or publishing his work, Galileo continued to study the skies in secret. Despite his isolation, Galileo's influence on the scientific community was profound. His work laid the foundation for future luminaries, like Sir Isaac Newton, who later developed the laws of motion and universal gravitation, building on Galileo's findings. The importance of Galileo's contributions to science can hardly be overstated, and his legacy endures to this day. In a poignant conclusion to this story, the Catholic Church eventually recognized its mistake. In 1992, over 350 years after Galileo's trial, Pope John Paul II formally apologized, acknowledging that Galileo had been right all along. Galileo's relentless pursuit of truth in the face of opposition serves as an enduring symbol of the power of scientific inquiry. His discoveries not only reshaped our understanding of the universe, but also demonstrated the importance of questioning established ideas and pushing the boundaries of human knowledge. Today, modern astronomers continue Galileo's legacy, peering deeper into the cosmos with advanced technologies like the James Webb Space Telescope. These modern tools allow us to explore galaxies far beyond what Galileo could have ever imagined, revealing new mysteries and deepening our understanding of the universe. Galileo's story is a testament to the enduring human spirit of exploration and discovery. If you're as fascinated by the wonders of the universe as Galileo was, there's always more to learn and discover. Stay curious, keep asking questions, and never stop exploring. For more captivating stories like Galileo's, subscribe to Tech Titans, where we dive deep into the minds and discoveries of the world's greatest scientists. Join us as we continue to explore the frontiers of science and technology, uncovering the mysteries of our universe and beyond. Don't miss out. Click on bell icon and be part of the journey to the stars.